Okay, so you know that feeling you get, right? When you're like bombarded with all this AI stuff,
Oh, yeah.
terms like agentic AI,
Yeah.
and especially MCP servers.
Right.
I feel like it's everywhere.
Yeah, it's very buzzy.
It is. It's super buzzy. It feels like a really big deal.
Mm-hmm.
But I think when most people hear that, when they hear like MCP server,
Yeah.
they're kind of like, okay, I get it. It's important. But what is it?
Yeah, exactly.
And so that's what we're hoping to tackle today.
Exactly.
Our mission, and I mean, I think this is a rock solid guaranteed mission, is to fully demystify these MCP servers.
I love it.
We are going to dig deep, understand their potential, and even see like how they're built
Yes.
behind the scenes.
I'm excited.
And trust me, we're going to make this engaging and fun.
Yeah, because it sounds very technical on the surface.
It does.
And there are definitely technical aspects to it.
For sure.
But the core idea, I think, is surprisingly easy to grasp once we start breaking it down.
Yeah.
And you've likely even encountered the very early stages of this without even realizing it.
Exactly. And that's such a good point.
Yeah?
Because think about it. Think about those AI coding helpers that are out there.
Yeah.
You might have tried out Cursor or Windsurf, things like that.
Mm-hmm.
And you type in a prompt, you say, hey, Cursor, create me a simple web server in Node.js or something like that.
Right.
It starts doing it.
Yeah.
Like it starts creating files, it starts installing packages, it starts writing the code.
Yep.
Pretty neat, huh?
Yeah, absolutely.
Now, here's something I've been wondering.
Okay.
Why don't we see that same kind of magic
Right.
for like other complex software? Like imagine if I could tell Premiere Pro, hey, edit this video for me based on this description.
Right.
Or if I could tell Figma, design an entire user interface from this text prompt.
Yeah, it sounds almost futuristic, right?
Yeah.
Yeah.
Super futuristic. Why isn't that here yet?
It's a really insightful question.
Yeah.
And I think the reason we don't see those widespread capabilities yet, and maybe even the key to unlocking those capabilities in the future,
Yeah.
lies in this concept of MCP servers.
Oh.
It's like this crucial piece of the puzzle
Okay.
that could potentially revolutionize how AI interacts with all sorts of applications, not just code.
That's it. That's the core of what we're talking about here.
Yeah.
So today, we're going to deep dive naturally into the specifics of what these MCP servers are
Yes.
and the MCP protocols that make them work.
Love it.
All right, so let's unpack this a little bit.
Right.
Where do we even begin to explain this?
I think the most logical starting point is with the underlying technology
Okay.
that makes all of this possible. We got to start with these large language models,
Okay.
or LLMs.
Right.
You've probably heard of the big ones, right?
Yeah.
ChatGPT,
Oh, yeah.
Gemini.
The big AI brains.
Yeah, exactly. So what's their fundamental job? What are they doing?
Yeah, what are they?
Well, essentially, they are incredibly advanced text completion software. They've been trained on an unbelievable amount of text data from all over the internet.
Yeah.
And they're really good at just predicting the most likely next word in a sequence.
So that's it.
That's it. They're really good at predicting.
Wow.
Like if I start a sentence and I say the quick brown, what's the next word?
Fox.
Fox. Exactly.
Yeah.
And they're really good at doing that, but on a massive scale.
So when I ask, let's say, ChatGPT a question, and it gives me this like seemingly intelligent answer, it's not actually answering in the way that like a person would understand and respond.
You got it. It's not understanding in the way that we understand.
Wow.
It's generating a sequence of words that is statistically the most probable,
Okay.
given all the data it's been trained on and the context of your prompt.
I see.
They're sophisticated prediction engines,
Right.
not, beings with like genuine understanding.
That makes.
And this distinction is really important when we start talking about what these LLMs can and cannot do.
Okay.
Because they can do a lot.
They can.
They can write essays, generate code, even those database queries I mentioned earlier.
Right. Right.
But they can't independently do things like send emails or run those queries.
So what's the limitation there?
The limitation is that an LLM, in its pure form, operates in this realm of text.
Okay.
It doesn't have this built-in capability to interact with external systems.
Oh, I see.
It can predict the code for sending an email, but it doesn't know how to connect to your email server,
Right.
handle authentication, and actually send the email.
Got it.
Similarly, it can generate a perfect database query in text form,
Right.
but it can't actually connect to your database and execute that query.
Right. Great.
It needs some help to do that.
Okay, so this brings us back to Cursor and Windsurf.
Right.
How do they bridge that gap? How do they go from just predicting code to actually creating files? Installing packages on my computer, this is where it gets really interesting.
It is, yeah.
So what's going on there?
So the key is that these tools are specifically designed to interact with the LLM.
Oh, okay.
They don't solely rely on the LLM's prediction abilities.
Okay.
They enhance it
Okay.
with specialized tools that are built for particular tasks.
Oh, interesting. So what kind of specialized tools are we talking about?
So in the case of like a Cursor or Windsurf, you might have a tool that is specifically designed to perform internet searches,
Right.
like to look up documentation or
Right.
find relevant code examples.
Oh, interesting.
And then you might have another tool
Right.
that's built for directly editing files on your local file system.
I see.
That's how they can create, modify, and save code.
Okay, got it. So it's not the LLM magically manipulating my computer.
Right.
It's these dedicated tools
Yeah.
that are actually following its instructions.
Exactly. They act as like an intermediary
Interesting.
between the LLM and the outside world.
Huh.
And the potential is there to build a lot more of these tools.
Okay. So could we see tools for Premiere Pro that understand video editing commands?
Absolutely.
Or for Figma that can interpret UI design requests?
Absolutely.
All
Yeah.
right.
If you can define the specific actions
Okay.
that need to be performed within those applications.
Right. Yeah.
Let's say updating a video timeline in Premiere Pro
Mm-hmm.
or creating UI elements in Figma.
Yeah.
If you can imagine that, then theoretically you could build tools that an LLM could instruct.
Okay, so this raises a question for me then.
Okay.
When all these different tools are being developed,
Right.
is there a standard way for them to communicate with these LLMs?
Yeah,
Because it sounds like it could get very chaotic very quickly.
it does.
Yeah.
And that's precisely the challenge.
Yeah.
Until very recently, there wasn't really a widely accepted standard protocol for this communication.
Okay.
And this lack of standardization is a major reason why we haven't seen this type of AI integration
Right.
become widespread across all kinds of software.
Makes sense.
But that's where this concept of MCP comes in,
Oh.
Model Context Protocol.
I'm excited to learn more about this, okay?
Yeah.
So let's dive into MCP then.
Okay.
I've been hearing the term MCP server
Yeah,
quite a bit lately.
right.
What exactly is an MCP server?
Sure.
And like, how does that differ from a regular server that I might already be familiar with?
Yeah, so let's think about it this way.
Okay.
We have like a client application.
Right, like Cursor or Windsurf.
Right, exactly.
Okay.
It needs some kind of back-end infrastructure
Okay.
to perform actions beyond just like generating text.
Right.
Traditionally, this would just be a regular server,
Okay.
handling requests, using its own internal logic and tools.
Mm-hmm.
But the emerging idea is that these servers are increasingly being designed specifically
Okay.
to facilitate interaction with these AI models.
Oh, okay.
We're starting to call these MCP servers
Okay.
to really emphasize this AI-centric functionality.
Okay, I got it.
So it's kind of like a new way of thinking about servers
Yeah,
in the age of AI.
I like it. So what does an MCP server do then?
So at its core, it receives prompts from the client application.
Okay.
And this is important. It can also understand the context of any relevant files or information
Okay.
that are provided by the client.
Okay.
Then using those specialized tools that we were discussing,
Right, right.
you know, a tool for writing files, another one for reading documentation online, or even one for analyzing console errors.
Yeah.
It executes the instructions
Right.
that are derived from the prompt.
Okay.
So it acts as this sort of bridge
Right.
between the AI model and the actual execution of tasks
Got it.
in the real world.
So you mentioned earlier tools for MongoDB operations like
Right.
read, update, delete, and connect.
Yeah.
That sounds really similar to how REST APIs work,
Mhm.
where you have different endpoints for
Yeah.
different actions.
It's an excellent analogy because in a sense, an MCP server exposes a set of capabilities through these tools,
Okay.
much like a REST API exposes functionalities through different endpoints.
Right.
But the key distinction here
Okay.
is that instead of a human developer
Right.
directly interacting with those API endpoints,
Yeah.
you have an AI model
Okay.
that's interpreting a natural language prompt
Right.
and deciding which tool to utilize
Interesting.
and how to use it.
Okay, so the lack of a standard protocol
Right.
was really the bottleneck here.
Yeah, that's it.
Every application or every company
Right.
was essentially inventing its own language for its AI to talk to its own set of tools
Exactly.
on its own servers.
Yeah, you could think of it as like a Tower of Babel situation.
Oh, okay.
Where everyone is speaking a different language
Right.
and no one can really understand each other.
That makes sense.
And it made it much more difficult for different systems and different AI models to work together.
And so this is where MCP, the Model Context Protocol, rides in to save the day.
Precisely.
Yeah.
It comes in and says, hey, we need a common language.
Okay.
So MCP, the Model Context Protocol,
Yes.
is a set of standards
Okay.
that was developed by Anthropic, the company behind the Claude AI model.
Okay.
And their goal was to establish a common language, a set of rules
Oh,
for how AI models can interact with these external tools
right.
and access the relevant context
Mm-hmm.
in a consistent way.
Okay, so MCP itself isn't like a piece of software.
No.
It's more like a set of guidelines, a framework.
That's a perfect way to describe it.
Okay.
It's a set of standards, much like the web standards
Right.
that we use every day.
Like HTTP status code.
Yeah, exactly. Like those 200 OK messages.
Right.
Or 404 not found.
Right, yeah.
Or authentication protocols like OETH 2.0
Right.
that let different applications share information securely.
Yeah, okay, so it's like that.
Yeah, it's that kind of thing for AI.
Got it.
MCP defines how the different components of an AI-powered system should interact with each other.
Okay, so what are like the key sections in this MCP rulebook? Like, what are the core components that it defines standards for?
So there's several really key aspects.
Okay.
The first one, let's consider models.
Okay.
MCP is designed to be what we call model agnostic,
Okay.
which means that any MCP server that adheres to these standards
Okay.
should be able to work with a variety of different AI models.
So it's not locked into just using ChatGPT or just using Gemini.
Exactly,
Oh,
yeah.
okay.
So whether it's Claude or ChatGPT or Gemini,
Right.
or even potentially older or more specialized models.
Interesting.
The idea is that this protocol should work with all of them.
So you could swap them out?
You could, potentially.
Okay.
And these models, they're not limited to just text.
Right.
They can handle different types of data.
Like images, video, things like that.
Exactly, yeah.
Huh. Wow.
And the overarching goal of MCP is to enable these models to interact with really any type of system or data.
So it's like a universal translator almost?
In a way, yeah.
Between AI and all these different applications.
I got
That sounds really powerful.
it's potentially very powerful.
So it's not locking you into a specific AI.
Right.
What's the next important piece of this puzzle?
So the second really crucial component is context.
Okay.
We touched on this earlier.
Yeah.
But it's so fundamental.
Yeah.
For an LLM to provide you with accurate and relevant predictions
Okay.
or instructions, it needs context.
Right.
It needs to understand the specific situation.
It makes sense.
Remember our earlier example of the word fan?
Yeah.
It could refer to like a devoted admirer,
Right.
or it could refer to a cooling device.
Right.
And the meaning completely depends on the surrounding context.
Yeah.
So how does MCP tackle this challenge of providing relevant context to an LLM?
Yeah, how does it do that?
So this is where those MCP servers really shine.
Okay.
They act as intermediaries
Okay.
that can provide this tailored context to the AI model
Right.
based on the specific task
Okay.
and the user's request.
Right.
So think back to our scenario of checking for an error
Yeah.
from your local code repository
Right.
within GitHub issues.
Yeah.
Or maybe your company's Slack channel.
Right.
An LLM doesn't inherently have access to that real-time
Right.
private information.
It makes sense.
It's not connected to those systems.
Yeah.
So this is where the MCP server steps in.
Okay, so what does it do?
It can be specifically built to fetch the latest issues from a particular GitHub repository
Okay.
and then provide that information as context to the LLM.
Oh, that's cool.
Or another MCP server could be designed to grant the AI limited access
Right.
to a specific Slack channel,
Okay.
allowing it to search for relevant discussions.
I see.
So the MCP server acts as this bridge,
Got it.
giving the AI the necessary contextual awareness that it wouldn't otherwise possess.
That's really cool. Okay, so how can this context be provided
Yeah.
within the MCP framework? Are there like different methods?
There are. So Anthropic has outlined several key ways
Okay.
to provide context through MCP.
Mm-hmm.
And the first, and perhaps the most direct, is through tools,
Okay.
which they also sometimes refer to as functions.
Got it.
And these are literally pieces of code, functions,
Right.
that the MCP server can call to retrieve data or perform actions.
Okay.
So if Cursor, for example, uses a tool to read a file from your computer,
Right.
that's an example of context being provided through a function call.
Okay.
The tool encapsulates all that logic
Right.
for accessing the file system. And then it provides the relevant file content as context to the LLM.
Okay, that's cool.
The second method is through resources.
Okay.
This involves providing additional files or data alongside the function call.
Okay.
So think about like attaching a CSV file to a function that analyzes data.
Okay.
Or, as you see in Cursor,
Right.
you can provide the content of your JavaScript or TypeScript file
Right.
along with your prompt.
Yeah. Okay, cool.
So sometimes the raw data itself is the most crucial context.
That makes sense. So what are some of the other ways that MCP handles context?
So another interesting method, though it's probably less common right now, is sampling.
Okay.
And this involves using different AI models for different parts of a workflow
Interesting.
and allowing them to share context.
Okay.
So for example, let's say you are working on a project
Yeah.
and you need some marketing copy.
Right.
You might use Claude for that because it's really good at that.
It's very creative.
Very creative, yeah.
Okay.
But then you might want to use a different image generation model
Right.
that can understand and incorporate elements from that copy.
Oh, wow.
And that would be facilitated by MCP's context sharing capabilities.
Okay.
So you're using different models for different parts of the task.
That's really clever.
Yeah.
Okay, and what about the last method for providing context?
So the last one is through prompts.
Okay.
So the client application always provides this initial prompt,
Right.
but the MCP server can actually enhance this prompt before it gets sent to the LLM.
Oh, interesting.
It might add more specific instructions,
Oh.
clarify the desired outcome,
Okay.
or provide additional constraints based on the context that the server has access to.
I see.
And you've probably seen this in tools like Claude,
I think so, yeah.
where they have features like enhance this prompt.
Yeah, I have seen that.
So the MCP server can kind of refine your initial request
Right.
and give the LLM even clearer guidance.
Okay, I like it. So we have models, we have context. How does the client application actually interact with the MCP server?
Right.
Is it like a direct line of communication?
So the client application interacts with the MCP server through the AI models.
Okay,
So the client sends a prompt to the AI model.
right?
And the model, because it understands the MCP protocol
Right,
and the tools that are available on the MCP server,
right.
it decides which tools to use
Okay,
and how to kind of orchestrate them
okay.
to fulfill the user's request.
I see.
The MCP server then executes those tool calls
Okay.
and returns the results back to the AI model,
Mm-hmm.
which then formulates a response
Right.
back to the client application.
Okay, so the AI is like the conductor of this whole interaction.
Exactly. It's
Fine.
orchestrating everything.
Okay. And you also mentioned protocols
Yes.
as a core component of MCP.
Mm-hmm.
We understand models, we understand context,
Right.
but what does the protocol part involve?
So the protocol is essentially the set of rules and standards
Okay.
that govern how all these different components, the client, the MCP server, and the AI model,
Right.
communicate with each other
Okay.
in a consistent way.
Right.
It's like, remember that military protocol analogy?
Yeah.
It defines the precise procedures and formats for exchanging information.
Okay, so it's all about establishing this consistent way for them to talk to each other.
Exactly, yeah.
You mentioned briefly something called a reflection request
Yeah.
as part of the MCP protocol.
Well,
What
yeah.
is that all about?
So we've talked about the models, the context. Now, how do these different players, the client, the server, the AI, how do they actually communicate in a standardized way?
Right.
And that's where the protocol aspect of MCP comes in.
Okay.
And a key part of that is something called a reflection request.
Okay.
The reflection request is essentially a way for the client application, or even the AI model itself,
Mm-hmm.
to discover the capabilities of a particular MCP server.
So it's like asking the server, hey, what can you do?
Exactly. It's like saying, hey, what tools do you have available? What kind of inputs do they expect? What kind of outputs do they produce?
Okay.
And this is a little bit different from how you might explore the endpoints of a traditional REST API
Right.
or the schema of a GraphQL API.
Okay.
The MCP reflection request is specifically designed for AI interaction.
So it's for the AI to automatically understand what the MCP server can do without needing a human to like manually configure everything?
Exactly, yeah.
That sounds incredibly efficient.
It is, yeah.
Can we visualize this a little bit more? What does a simplified architecture of an MCP system look like?
Okay, so imagine 3 main players.
Okay.
You have the client,
Okay.
and as we've discussed, this could be a wide range of applications.
Right, like Cursor, a game, Premiere Pro, anything.
Exactly, yeah.
Okay.
From a code editor like Cursor to a game to a video editing suite like Premiere Pro,
Right.
the client is what initiates a request or triggers an action,
Okay.
often through a simple user interaction.
Like typing in a prompt or clicking a button.
Exactly, yeah.
Okay, so the client starts the process.
Right.
What's the next piece?
Next, you have the MCP server.
Okay.
And currently, these servers are often what we call stateful.
Stateful, meaning they remember past interactions.
Exactly, yeah.
Okay.
They might keep track of the current project you're working on,
Right.
or the history of your requests.
Okay, so it's kind of remembering where you are in the conversation.
Yeah, exactly.
Got it. So the MCP server receives the request from the client. How does it communicate back and forth?
So there are a couple of primary communication methods.
Okay.
One is server sent events, or SSEs.
Okay.
This allows the server to proactively push updates to the client.
Okay.
So for example, if a long-running task is in progress,
Yeah.
the server could send progress updates to the client as it goes.
All right.
The other method is through message endpoints.
Okay.
And these are quite similar to traditional REST API endpoints,
Okay.
where the client sends a request and the server sends back a response.
Okay.
But what's great about MCP is that either of these methods,
Okay.
or even a combination of them,
Right.
can be used.
Okay.
And the underlying code to implement these is generally quite straightforward.
Oh, cool. So it offers a lot of flexibility in how it communicates updates and responses.
Exactly, yeah.
Okay. Can we get a bit more concrete with an example?
Sure.
You mentioned building an MCP server for MongoDB.
Right.
What would that actually look like?
Okay, so first of all, there are MCP Server SDKs available in popular programming languages,
Like what?
like JavaScript,
Okay.
Java,
Mm-hmm.
which makes it much easier for developers to get started.
Right.
And imagine a simplified code snippet in JavaScript.
Okay.
You'd begin by creating an instance of an MCP server class.
Okay.
You would give it a name,
Right.
maybe a version number.
Okay.
This is essentially setting up the basic structure of your server.
All right, so that's the initial setup.
Yeah?
How do you then connect it to something like MongoDB?
Right, so next you would define methods
Okay.
for interacting with MongoDB.
Okay.
This would involve writing standard database connection code.
Okay.
Nothing AI specific at this stage.
Right. Right.
You would have functions to connect to your MongoDB instance,
Mm-hmm.
handle authentication,
Right.
interact with your database collections.
So this is all like the basic infrastructure
Exactly.
that you need to actually communicate with the database.
Yeah, you're setting up the plumbing
Got it.
before you bring in the AI.
Okay, so where does the AI aspect come back into play then?
So the AI integration happens when you start registering MCP operations.
Okay.
So let's take the example of a get document operation.
Okay.
You would define how a user might naturally phrase a request
Right.
for this operation.
Okay.
So maybe something like retrieve a document from the user's collection where the name is Alice,
Okay.
or even simply just get user Alice from the database.
Right. Okay.
And the LLM,
Yeah.
understanding the user's intent based on these phrases
Okay.
and the registered operations,
Mm-hmm.
can then trigger the specific get document operation on your MCP server.
I see.
So the AI is understanding what the user wants,
Right.
and then it's saying, okay, I need to call this get document operation
Got it. Got it.
on the MCP server
Okay.
to get that information.
So what happens when that operation is triggered? What happens on the MCP server side?
Right, so the MCP server would first validate the incoming request,
Okay.
make sure that the user has specified a collection name, some
Uh-huh.
search criteria,
Okay.
and then it would execute what's called a handler function.
Okay.
This function contains the actual code
Right.
to query your MongoDB database
Okay.
based on the provided parameters.
Got it.
And then finally, it would retrieve the requested document
Okay.
and return it as a result back to the AI model.
So the crucial point here is that the LLM isn't directly accessing and querying the database.
Right.
It's instructing the MCP server
Yeah.
to execute this predefined and controlled function.
Exactly.
That makes sense. It's
Yeah.
like a separation of concerns almost.
It is.
The LLM understands what I want,
Yeah.
and then the MCP server actually knows how to do it.
Yeah, exactly.
Okay, and you mentioned an insert operation earlier. Would that follow a similar pattern?
It would, yeah.
Okay.
You would register this insert operation,
Right.
define the kinds of user prompts that might trigger it.
Right.
Like add a new product named widget with a price of $19.99.
Yeah.